Good day everyone, welcome back to our chemistry series. Today we'll be discussing atomic number, mass number and isotopes. Atomic number. The atomic number of an element is the number of protons present in the nucleus of the atom of the element. Atomic number of an element determines the nature of the atom and distinguishes it from atoms of all other elements. Important points to note: every element has a unique atomic number. The atomic number identifies an element. In a neutral atom, the number of protons equals the number of electrons. Now, why atomic number is defined by protons? The number of protons in an atom never changes unless the atom becomes a different element. Two neutrons can vary in atoms of the same element, called isotopes. Electrons can be gained or lost to form ions. Therefore, the number of protons is the most reliable way to identify an element. Below is an example of some elements and their atomic number. We have hydrogen with the atomic number of 1, helium with the atomic number of 2, carbon with the atomic number of 6, oxygen with atomic number of 8, sodium with atomic number of 11, chlorine with atomic number of 17, and they all have corresponding number of proton. The mass number. This is the sum of proton and neutron in the nucleus of an atom. It is also called nuclear number. It is represented by the symbol A. Mass number is equal to number of proton plus number of neutrons. Note: mass number counts only the particles in the nucleus, that is the proton and the neutron. Electrons are not included because their mass is very small compared to the proton and neutron. Atoms of the same element can have different mass number if they contain different numbers of neutrons. Such atoms are called isotopes. The mass number is always a whole number. Below is a table showing some elements, their number of proton, neutron and mass number. We have hydrogen with 1 proton and 0 neutron, and the mass number will be 1 plus 0, which is 1. We also have carbon with 6 proton and 6 neutron, and the mass number will be 6 plus 6, which is 12. Also, we have oxygen with 8 proton and 8 neutron, and the mass number will be 8 plus 8, which is 16. And we have sodium with 11 proton and 12 neutron, and the mass number will be 11 plus 12, which is 23. Now, the last concept we'll briefly discussing about is isotopes. Isotopes are atoms of the same element that have the same atomic number, same number of proton, but different mass number due to different number of neutrons. Now, in our next topic, we'll be discussing isotopes further and relative atomic mass. Atom representation. Atoms are represented in the form as shown below, where X is the atomic symbol, A is the mass number of the atom, and Z is the atomic number. We have some examples, and the first is from 2008. It states that find the number of neutrons in an atom represented by the symbol S4521. Now, for our solution, mass number is equal to proton plus neutron, which will make neutron to be equal to mass number minus proton. From the symbol, we can see that our mass number is 45 and electron 21. So our neutrons will be equal to 45 minus 21, which will make our neutrons to be equal to 24, and the correct option is B. Now, we have another question for NATEB, and it states that the number of protons in one atom of an element is generally called A, mass number, B, atomic number, C, nuclear number, and D, proton number. Now, the number of protons in an atom is generally called the atomic number, and the correct option is B. We have another question from 1997. It states that the mass number of an atom of element is the sum of its A, electrons, neutrons and proton, B, electrons and proton, C, proton and neutron, D, valence electrons. Now, the mass number of an atom is the sum of its proton and neutron, and the correct option is C. We have another example from 1998, and it states that an atom with 17 protons, 17 electrons and 18 neutrons has a mass number of, and we're given the option. Now for our solution, mass number is equals to proton plus neutron. Our proton is 17 and our neutron is 18, so that will be equal to 17 plus 18, which is equals to 35, and the correct option is D. We have our final question from 2004, and it states that the mass of an element is 27 and its atomic number is 13. What is the composition of the nucleus of its atom? A. 13 electrons and 14 protons. B. 13 neutrons and 14 protons. C. 13 protons and 14 neutrons. And D. 13 electrons and 14 neutrons. Now for our solution, since the mass number is 27, atomic number will be equal to proton number, which is equal to 13. So our neutron number will be equal to mass number minus proton, which is equal to 27 minus 13, which is equal to 14. So the correct option would be 13 electrons and 14 neutron, or 13 proton and 14 neutron, and the correct option is C. Here are some exercises for you to try your hands on at home, and for more insight on this topic you can check out the chapter 3 of our hidden facts chemistry textbook. You can get the hard copy in bookshops, or if you are interested in the soft copy you can get it at the website on the bottom of the screen. Thank you.